The newly traveled road helps Pagani become one of the very first car makers to employ discrete, active aerodynamic wings on its bodywork. The unique solution features 4 independent flaps, 2 at the front and 2 at the rear, which finesse the airflow across the corners of the machine and ensure an optimum balance between straight-line efficiency and cornering performance. The result is that engineers can tune the new Huayra Roadster to produce 1.8 Gs of lateral acceleration, which is a measurement of how much cornering force a machine can generate.
Basically, it's using the wind that's going over the car to push down on the car to give it more grip. And it can do it on one side, the other, or both.
The system allows the Huayra to maximize its downforce, or the vertical force pushing a car into the ground, while at the same time minimizing its drag, or air resistance that holds it back as it tries to go faster. During straight-line acceleration, the Huayra has a drag coefficient of just 0.3. Yet during heavy braking, when all 4 flaps deploy, the rating nearly doubles. The brand builds their active aero system from the ground up.
Non avevamo altre cose da studiare, sì, siamo andati a vedere come si muovevano i
We
flap.
didn't have other things to look at. We went to see how airplane flaps move. We saw how to integrate this to the suspension, but there wasn't a ready-made solution.
The active aerodynamic wings constantly manage the airflow passing over the body and help the Roadster dance to a monstrous 230 mph top speed. Faster than a jumbo jet at takeoff. Yet all the downforce in the world is wasted if a supercar doesn't have a set of grippy rubber tires to get the power to the ground. And when you're an exotic Italian hypercar manufacturer, there's only one place to push the limits of conventional tire technology. Automotive artist Orazio Pagani and his team of designers and engineers are attempting to up the ante and build a new, even more exclusive open-air roadster. They've already radically reduced the machine's weight, increased its strength, and honed the aerodynamics. Now they need to help the new ride grip the road. To do that, they turn to the experts at Pirelli. Preventing the tire from being the weak link is an incredible challenge, because the Roadster's massive V12 engine produces a monstrous 754 horsepower.
What is really important is a challenge on how to design a tire, how to design new material, new structure.
Conquering that high-performance tire challenge takes place deep underground, inside of Pirelli's highly secretive research and development facility. This clandestine location houses a variety of state-of-the-art testing cells. Designing an all-new tire specifically for the Huayra Roadster begins in an advanced prototyping cell, where a laser digitally traces a freshly engineered tread pattern onto a blank tire.
A laser machine is a device where a prototype tire is painted and you can, via laser, what the engineer wants, into a real prototype.
A talented craftsperson then expertly carves each prototype. It'll take half an hour to cut just one tire. All the slicing and dicing adds up fast. The team is able to remove more than 2 pounds from each Pagani spec'd tire. The less a tire weighs, the less energy that's required to move it. Next, they test the structural integrity of the prototype tire inside a high-speed dyno cell. The machine helps validate the footprint of the tire, or the part that touches the ground, to ensure that it doesn't deform at speed. The tire spins so fast that it's impossible to see any potential distortion without the help of a strobe light.
And so the strobo is really giving us the opportunity, filming what is happening into this phenomenon.
After countless hours spent pushing the new tire to its limit, the team discovers that it's capable of correctly holding its shape at a mega-fast 230 miles per hour. That makes the tires faster than the car they're fitted to.
The purpose is to measure and simulate any characteristics from the tire in use with the car. For instance, we can simulate cornering forces, loads.
Simulating those forces takes place on a multi-axis dyno, where they torture a tire to determine where its cornering limits lie.
If you have seen the machine working, you can imagine that the cornering force it can reach is more than 1,000 kilos.